The year is 1997. A car park in Wolverhampton's town centre had just partly collapsed. Engineers rushed to the scene to investigate. It looks like the top slab's own weight caused it to puncture and slide down the supporting columns. How did it happen? Who is to blame? Let's find out. In a typical RC building, you have the foundation, columns, beams, and slabs. That's all well and good until you try pass wires, pipes, ducts, and other services through the ceiling. It's not like you can just drill holes in the beams like you can in a steel building. So sometime last century, civil engineers decided that beams are for losers, and so designed slabs to be directly supported on the columns, thus saving that precious floor height. Flat slabs come in a variety of flavors like plate, waffles, vanilla, capitals, and drop panels. Flat slabs are great because they minimize depth, thus wasting less of the available building height. This matters for permits, this matters for earthquakes, and this really matters for real estate. Also, flat slabs require less formwork and easier to place reinforcement. Thus they are faster to build, and depending on the price of concrete versus the price of labor, could be cheaper than a conventional system. If you design a flat slab, there are two main considerations: deflections and punching shear. Speaking of punching shear, this is what happens when it's not designed correctly. This is the Piper's Row car park in the UK, after a 120-ton section of the top floor collapsed due to punching shear. It was built in 1965, and after years of partial repairs, it slowly deteriorated until it collapsed during the night of the 20th of March 1997. Luckily, no one was hurt, and the collapse did not lead to a pancake effect. A 116-page report from Dr. Jonathan Wood states that the damage was caused by bad detailing of the shear studs and corrosion in the reinforcement due to low cover and carbonation. What essentially happened was that the bond between the steel and the concrete was destroyed. But things are not as simple as that. In 1989, 8 years before the accident, Uwe Arup, the founder of Arup Group, was asked to inspect the car park for an assessment of its safety. Arup said that the structure did not need immediate repairs, but it was important to not reduce the margin of safety due to material deterioration. This advice was obviously not followed, as that was the root cause of the failure. 2 years later, in 1991, 51 square meters of repairs were carried out to the top slab, but it's not recorded which part of the slab was repaired. In the same year, a quotation for a full refurbishment was instructed, which would add concrete capitals to each column. This work was never acted upon. In 1996, a year before the collapse, a contractor inspected the car park for waterproofing repairs, when they found that the concrete slabs had deteriorated up to 60 millimeters in one bay. However, they were never contracted to repair this damage, and as they were not structural engineers, they could not evaluate damage themselves. The owners of the building ordered repairs without a full investigation of the damage extent. This is what the damage looked like. A month before the collapse, the owners instructed a structural engineering company to evaluate the damage. A week before the collapse, the engineers were instructed to prop the damaged slab at the column. While approaching contractors for the job, the 32-year-old structure collapsed at 3:20 a.m. on the 20th of March 1997. So, who was to blame? Was it the structural engineers for not propping the slab in time? Was it the repair contractor who did not warn the owners of the danger that covering up cracks would impose? Maybe it was the owners who did not take the offer for the full refurbishment. Or finally, was it the building standard used at the time which overestimated the shear strength of the slab? In response to this event, preventative measures have been taken. Eurocode 2, released in 2004, the successor to the British standards of 1997, has increased the safety factor for punching shear resistance of slabs with shear reinforcement. Also, some building owners have developed an inspection regime for identifying deterioration and damage using survey tools and regular inspections. Failures like this one are thankfully rare, but they can be an invaluable tool for prevention and mitigation of similar and possibly life-threatening events like this one in the future. That's all for now. Hope you learned something new, and I'll catch you all next time. See ya.